Hello, my class 8 students. Please open page number 47 from your physics book. We will now move on to atmospheric pressure. In our last class, we have learnt about pressure, that pressure is equals to force per unit area, where the force should be perpendicular on the surface and it is known as thrust. Now, as you have learned earlier, Earth is surrounded by a blanket of air which is known as the atmosphere. The atmosphere is divided into 5 layers and its main constituents are nitrogen, oxygen, carbon dioxide and water vapor. Therefore, we can imagine ourselves as living at the bottom of a large pool of air. Now, air exerts pressure on Earth. You have learnt in your junior classes that air has weight. A balloon which is inflated, that is, it is having air inside it, when hung, it is found that it is having certain amount of weight. So now we will learn that air also exerts pressure. The air that exerts pressure on the Earth is known as atmospheric pressure. So the atmospheric pressure is defined as the force exerted on unit area of a surface by the weight of the air above it. The more the air that is above us, the higher the air pressure will be. The atmospheric pressure is not same at all places of the Earth. We know that air gets thinner as we move up. The atmospheric pressure of a place also depends on its altitude, that is the height from the sea level. As we go higher, the density of air decreases and hence pressure decreases. Therefore, at great heights, the air pressure is low because there is less air above us. If you stand on the top of Mount Everest, which is over 8 km above the sea level, the air pressure is only about 30% of the air pressure of sea level. Now, since the air molecules are in constant random motion, the atmospheric pressure can also be said to be the result of collision of air molecules with any surface. Air exerts equal pressure in all directions. The atmospheric pressure on the Earth's surface at sea level is about 100,000 Pascal, that is 100 kilopascal. If such an enormous amount of pressure is acting on us, why do we not feel it? This is because the pressure of the blood and other fluids present in our body almost balances out the atmospheric pressure. So imagine the atmospheric pressure on the Earth's surface at sea level is such huge, but we do not feel it because of the presence of fluid and blood inside our body. It balances the atmospheric pressure. 100,000 Pascal is not a matter of joke, that is a huge pressure. Air pressure is measured with a device called barometer. Applications of atmospheric pressure. Drinking straw. You must have used a drinking straw. When air is sucked out of the straw, it causes a decrease in the air pressure inside it. Now, how is it possible that with the help of a straw, we can suck in the juice or the drinks that we are drinking? This is because when the air is sucked out of the straw, we are sucking the air out of the straw, it causes a decrease in the air pressure inside the straw. Inside the straw, there is no longer any air pressure. As a result, the atmospheric pressure on the outside forces on the liquid. And so the liquid now comes inside of the straw and directly to our mouth. This is known as suction mechanism. Syringe. When we pull the piston of a syringe out, we increase the volume of air inside the syringe. You have seen syringes in injection syringe, etc. This correspondingly decreases the pressure inside the syringe than that of an outside pressure, and hence it forces the liquid or the fluid into the syringe. So a syringe also works in the principle of atmospheric pressure. Rubber sucker. See the figure 3.14. When the concave surface of a rubber sucker is pressed against the wall, that is this surface, or any flat surface, the air between the two surfaces are squeezed out, leaving the pressure in the enclosed space much reduced. The external pressure, that is the pressure outside, forces acts on the sucker against the flat surface, resulting in the rubber sucker to stick to the flat surface. Next we are having tires and footballs. When you ride a bicycle, the air pressure inside the tire supports your weight as well as that of the cycle. Similarly, when we pump air into a football, the air pressure gives it shape so that we can play with it. A vacuum cleaner applies the principle of atmospheric pressure to collect the dust particles from a surface. So this much, if you learn about the applications of atmospheric pressure, this is enough. Same principle applies with medicine dropper as well. Now one more important thing, mountain climbing. Some people can feel their ears popping while climbing altitudes due to decrease in the air pressure. As we move high up, the air pressure decreases. The ears pop to balance the difference in the pressure between the outside and inside of the body. Next, move on to pressure exerted by liquids. Just like in the case of atmospheric pressure, the pressure at any point under a liquid is due to the weight of the liquid column above that point. If we try pushing down an empty mug into a bucket full of water, we will note that the mug resists being pushed down into the water. If you try this at home, you can see that in a bucket full of water, when an empty mug is pushed, the mug will try to move up. This happens because of the upward pressure exerted by water on the mug. Just as in gases, the pressure in liquids also acts in all directions. Remember children that pressure in a liquid is exerted on all sides, that is in all directions, and remains the same in all directions at a given depth. Pressure in liquid increases with depth. Pressure depends on the density of the liquid, and pressure is independent of the size and shape of the container that we are using. So pressure in a liquid depends on the following factors: height or depth of the liquid, density of the liquid, that is liquid pressure increases with increase in density and liquid pressure increases with increase in height. Now, deep sea divers have to wear specially designed suits to protect themselves from huge pressure of the water underneath. The walls of the dam are made stronger at the base than at the top. That is because as we move down, the pressure increases. So the water pressure down here will be much more compared to the water pressure up here. So the dams at the base of the dam are made much more broader in order to withstand this water pressure. So that is all children. Hope you have understood this chapter. I will give you the question answers. Please copy it down in your classwork copy and start learning them. We will move on to the next chapter in our next class. Thank you class.